Hello everyone, I'm Trevor Anderson with Nerdware, and today we're talking Terraform module design principles. How to create modules that are actually useful to people, how to structure them in a manner that facilitates rather than hinders development, and for more experienced devs out there, how to plan out a collection of modules. Let's dive in. We'll split this topic into two categories. Module structure, which we can think of as the general composition of any single module, and what goes where, which we can think of as deciding which resources to put in each module within a collection of modules, and how to make good decisions in regard to planning out your intermodule dependencies. First up, in regard to module structure, something that applies to every module for virtually every use case is you'll want to keep it small. This is important for a number of reasons, but perhaps most importantly, smaller modules are just easier to use and maintain. In regard to usage, your module's users will be reviewing command output from Terraform apply operations, which can be quite lengthy. And if they have to comb through thousands of lines to look for one specific thing, it's going to slow down development and frustrate everyone involved. And on the development side of things, larger modules create unnecessary overhead. Generally speaking, the more resources a module contains, the more likely it is that 1, it will need to be updated more frequently, and 2, that it will be used in more places. And so whenever the module is changed, you therefore have a greater number of version bump commits that need to work their way through your organization's CI/CD pipeline. Smaller modules, less overhead. Next up, you'll want to keep your module structure flat, which is to say you should absolutely avoid using nested modules. First and foremost, nested modules are a sure sign that the module is violating the keep it small principle and should therefore be broken up into smaller separate modules. But it also almost always reflects the implementation of embedded rather than injected dependencies, which diminishes a module's flexibility. We'll come back to this topic of injected dependencies in the what goes where section. Last but not least for module structure, wherever possible when you need more than one of something, use maps and sets instead of lists. In regard to resources, this means using the for each meta argument instead of count. The reason being, if a collection of resource state refs are index-based, then adding or removing low index elements creates an unnecessary diff on higher index elements. Not only does this clutter the command output from apply operations, but quite often this will mean the end user has to choose between unnecessarily destroying and recreating those higher index elements or running time-consuming state move commands. You'll often hear this concept referred to as minimizing the blast radius of expected changes. Now, that's all well and good for one individual module, but what about a collection of modules? First up, for resources that will be commonly used throughout many modules, think IAM roles and policies, S3 buckets, KMS keys, put them in their own modules. It's quite often tempting to include those alongside the resources which immediately depend on them, but do yourself and your team a favor by avoiding this temptation. Consider resource and IAM policies. Some, like this one, are entirely fixed and can be hard-coded in your module ostensibly without issue. This is often the case for assume role policies. Others, however, will require ARNs and other values to use in resource and condition fields. You could keep the fixed values in the module code, parameterize the inputs, and merge them together. But this means that if you want to review the policy in its entirety, you now have to look in multiple places and/or you've no choice but to use the console or CLI, API queries, etc. Some will have a sufficiently high number of parameters such that it just makes more sense to parameterize the whole policy as a JSON encoded string. This is often the case anytime a policy may have varying conditions or condition operators depending on which input values are provided. And before you know it, you have policies and bits and pieces of policies scattered absolutely everywhere. This makes it exceedingly more difficult to review your IAM policies collectively. And imagine the headache that would ensue if, say, you wanted to add tags to a subset of your policies, or if perhaps AWS released some new awesome condition key and it's your job to implement it, but it must only be applied to certain policies within certain contexts. So clearly, we need to isolate key components of our infrastructure, like policy auth mechanisms. And if you're ever unsure about whether resources belong together in the same reusable module, consider taking a hint from the Terraform registry. Every provider's documentation in the registry groups related resources within these collapsible menu categories, which can often serve as reasonable targets for reusable modules within a collection. If you're working on a reusable module and considering including a resource from another category, there's a good chance it doesn't belong there. This won't be the case 100% of the time. Some categories are tightly coupled or contain resources for which it just doesn't really make sense for them to have their own distinct module. Auto-scaling groups come to mind that arguably fit this bill, but the vast majority of the time, this guideline will serve you well. Last but certainly not least, and I cannot recommend this highly enough, supercharge your Terraform dependency management with Terragrunt. Now, there's a tremendous amount of functionality that Terragrunt brings to the table, all of which I'll be covering in an upcoming video that takes a deep dive on Terragrunt and how to get the most out of it. But for now, we'll keep our focus on dependency management. You're not going to want to miss that though, so be sure to subscribe and hit the bell icon to be notified when that drops. Now, with Terraform alone, managing dependency relationships and other inputs across various environments, regions, and cloud accounts can be a real pain that winds up discouraging good design principles like the use of injected dependencies. With Terragrunt, however, we get some really excellent tools that provide the flexibility we need to tame this complexity. In this Terragrunt config for an S3 bucket, we have dependency relationships defined using dependency blocks, which allow us to define dependencies in a declarative syntax and extract output values from other modules to be used as inputs for this bucket's resource config. Note that we can also provide mock values for these injected dependencies and optionally even merge them with actual output values once these resource configs have been applied. Now, if you're wondering, hold on a sec, where are the Terraform and provider blocks? Well, those are provided here using include blocks, which can be used to bring in values from any other Terragrunt file. Included values are shallow merged by default, but they can also be deep merged, not merged at all, or we can set an include blocks expose property to true to provide access to the included file's values, in which case we could use them however we'd like. Here, root.hcl provides the actual Terraform block and remote state config. And as you might have guessed, provider.hcl provides the AWS provider block. Note that since we now have the ability to inject variables specific to any given resource, environment, region, account, etc., we only need to define these blocks once within the entire repo. Now, instead of having multiple copy-paste remote state configs and having to manually switch workspaces imperatively on the command line, we have versioned dependency relationship definitions, which can be managed with our existing CI/CD infrastructure. To really show off what Terragrunt can do in this regard, let's take this config one step further and use these two block types in combination. Let's say we know for certain that all S3 buckets within this organization will have two dependencies, a KMS key for server-side encryption and a secondary bucket for access logs. Well, we could then move these dependency blocks into a separate file. In this example, we'll place it here in Common Resources. And now we can utilize the blocks we've defined here via an include block, like so. Now, for every bucket within this organization, we no longer have to define these relationships in each individual bucket's resource config. We've now defined it in just one place and can override it if there's ever need to do so. All this functionality that Terragrunt brings to the table in regard to how our modules are ultimately consumed affords us the flexibility to keep our reusable modules light and flexible, and avoid the temptation of convenient anti-patterns as a means to overcome the limitations of other tools. And there we have it. If you liked this video, and I hope you did, please be sure to like and subscribe and check out more nerdware content on how to code your cloud. Thanks.